Hello, so we're going to start the second half of, let's see, what's the top of it? It's called Types of Circuits in Ohm's Law. So now we're going to practice what we just read about. So the first thing we're doing is matching. Hopefully my pen is still set up from this. And I'm just going to bring the correct, they're just giving me the value of 4 for all of these with different measurements. So we have to put the types of units with the proper quantity or thing we're solving for. So I is current, so current is measured in amps. So I'm going to write, this does not look like my pen, 4 amps. I'm going to go ahead and cross this out. So then we have V is for voltage, so I'm looking for volts, and I found it right here. So I'm going to write 4 volts. R is for resistance, which is measured in ohms. So I'm going to write 4 ohms. And let's see, newtons is force, so I'm going to write 4 newtons here. And I don't think we went over this yet, but joules is a measure of energy. And so this is going to be 4 joules. And I believe we go over this later on. And then P is for power. And we're going to say 4 watts here for power. And again, like I said, this is, I believe in our next paper we go over it. Label the diagrams as parallel or series. You can see 2 paths right here. They're very clear. You can even number them. So I'm going to call this parallel. This one, basically, the next one looks like a nice little closed series circuit, which it is. The unit for current is, the abbreviation is, so the unit for current is what? It is amps, but our abbreviation is I. The unit of voltage is volts, and the abbreviation is small v. Actually, they put a big V there, big V. The unit of resistance is ohms, and the abbreviation is the symbol, which is kind of neat. And then series or parallel circuits, we have to tell which is which. So you can write S or P. Only one path for electricity that is series. So think of parallel as 2 lines, which means 2 paths. So that might make you or help you remember that parallel means more than one path. So think of parallel lines. You know there's 2 lines, like if you're thinking math, or I don't know what else you'd use parallel in besides that. Maybe in cartography, map making or something, I'm not sure. Dependent paths. Dependent paths, a series of dependent paths. So we're going to say that there's more than one path, so I'm going to call this parallel. How your house is wired, parallel. Independent, you know what? I want to change this one to series. Dependent means that it is dependent upon something else. So let's say it's series. Independent current paths, will definitely say that that's parallel. Sorry if that looks like a D. Can turn off one light without turning others off, definitely parallel. If you turn off one light, all the lights turn off, that's definitely series. More than one path for electricity to flow, that is definitely parallel. Okay, looks good. So if you increase the voltage, the current, this means bigger battery, the current will increase. If you decrease resistance, the current will increase. It's like not making, it's like keeping the flow the same. So if you decrease it and actually make it smaller resistance than what's already there, then that's definitely going to increase the amount of electrons flowing through that point on the circuit. If current increases, the resistance is going to increase along with it, but it's not going to be changed. Well, actually, the resistance will be, I take that back, it's going to be decreased because it won't be as strong as it was before. If you increase the resistance, if you increase the current, the resistance isn't going to be as strong as it was before. So they go hand in hand. If voltage is decreased, the current will increase or decrease. So if the voltage is decreased, the current is definitely going to decrease because you're not going to have the battery pushing out as many electrons, so current decreases. If current decreases, the voltage must also decrease. If there's more current, will a light bulb be brighter or dimmer? It should be brighter. Because if there's less current, maybe the battery is starting to die, so it becomes dim. And I actually have right here, we can check our work. Right here, let's see. Hey. So we have increase, increase, decrease, decrease, decrease. Yep, got it right. And then will lights turn on or off and why? So this is going to be a no. And why is that? Oh wait, this is going to be our yes. Take that back. This is wait a minute here. What's the difference between these guys? Uh-oh. Moved something. Right. What's the difference? I totally forget. So the battery's going the wrong way. So no, these batteries are flipped. This battery needs to be the same. See, these two batteries look alike? And this one is not the same as this one, so no. Batteries going in opposite direction. This one, they're going in the same direction. But this one's also a no. Why? Switch is open. The current's not going to be able to flow. So no, no. All right, how much current goes through a circuit with a 12-volt battery? I'm right up here. Maybe I'll change to this guy. Right there. How much current goes through a circuit with a 12-volt battery and a 3 ohm resistor? So what do? I look at my chart. So we have voltage, we have resistance, so we're looking for current. So if I go up here and I have V and R, I'm looking for I. So I'm going to use the formula I equals VR. Go to my pen. Still not there. I equals VR. Current equals voltage divided by resistance. That's my step one. Then I'm going to equal it to my 12 volts, and then my resistance is 3 ohms. And my current is 12 divided by 3 is 4 amps. Easy peasy. I just circled that really messily. Find the current in a circuit with 6 volts battery and 2 resistor. So we're looking for I again. The resistor is going to be your ohms, right? And so again, same exact setup. We have I equals V over R. we have our voltage is 6 volts, and we have 2 for our amps. I'm sorry, for our resistance, little ohm thing. 6 divided by 2 is 3 amps. And that is our answer. And then last one, how much voltage gives 5 amps of current through a 3 ohm light bulb? So we're looking for voltage this time. So we need to switch this around. And if you can do it in your head, but you don't have to. So if you can't do it in your head, you make your little triangle. V's on top, R, then I. I'm looking for V, so I can see if I put like my finger or something or pencil tip over V, I'm left with V equals I times R. So V equals I times R. So equals, current is 5 amps times 3 ohms. So my voltage is 15 volts. There we go. That's my answer. And then we're in the lab. Told you you didn't need to do this. You could try it or probably even almost do it in your head, figuring it out. But again, I said you didn't have to do it. Okay, so we're done with that page. Yay.